Alright, finally we come to the home stretch, the last two pages of solutions. 66 through 71. In number 66, we have find the values for sine of t and cosine of t for t equal to 5 pi over 3. This is dealing with reference angles, if you remember them. I would say that 5 over 3 pi is greater than 1 pi, right? So I know that I have at least half a revolution. Is it equal to more than 3 over 2 pi? Well, let's see. Let's take 5/3 pi and subtract it from 3 over 2 pi. Take 3 over 2 pi and subtract it from 5 over 3 pi. Well, 5/3 minus 3 over 2 is 10 over 9 over 6. And that becomes 1 over 6. So we have 1 pi over 6. We remember that this is equal to 30 degrees. So this right here, we would continue on so this whole revolution between here and what is shown here is 5/3 pi. And from 3 over 2 pi to 5/3 pi, this is the same thing as 30 degrees. Therefore, this angle right here, which is the angle that you use to find the value of sine and cosine, our reference angle is 60 degrees. For this course, you should memorize what the values for sine and cosine are for 0, 30, 45, 60, and 90 degrees, and what the corresponding radian values are. We know that sine is negative in the fourth quadrant, and we know that cosine is positive in the fourth quadrant. So we have cosine of 5/3 pi equals 1/2, and sine of 5/3 pi equals negative 3 over 2. To give you an easy way of memorizing the values of sine and cosine in the first quadrant, you can draw a little table. You can say 0, 30, 45, 60, and 90. We have sine of theta, cosine of theta. So these are values of theta. And here we start off with, let's see, we have 0, 1, 2, 3, 4. And then we go in the reverse order for cosine, 4, 3, 2, 1, and 0. We take half of everything. Over 2, over 2, over 2, over 2, and over 2. And over 2, and over 2, and over 2, and over 2, and over 2. And then we take the square root of the numerator of that. Square root, 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 square root. So these are actually, when you evaluate them, equal to the values of sine and cosine for different values of theta. And it's a nice little mechanism for remembering that the sine and cosine of theta for theta equal to 45 degrees is equal to square root 2 over 2. And that the sine of 90 degrees is square root of 4 over 2, which is 2 over 2, which is 1. Alright, number 67. And you can also use this to find, tangent of theta. Because tangent of theta is equal to, sine of theta over cosine of theta. So you would, say, tangent of 30 degrees is equal to 1/2 over square root 3 over 2. And you would evaluate that until you came out to some nice single fractional expression or value. All right, so number 67. It says that suppose that t is somewhere between 0 and pi over 2. So we know that we are somewhere in the first quadrant, right? Our triangle looks something like this, where we have 0 and pi over 2 as values. And it says that cosecant of t is equal to 4, right? So cosecant is the same thing as 1 over sine. So this means that sine... Oh, okay. Also, cosecant, let's see, cosecant of t would then be equal to the hypotenuse over the opposite, right? Because sine is equal to the opposite over the hypotenuse. So that means that I could write this as 4 over 1, right? So that means that I could identify my hypotenuse with a value of 4 and my opposite value with a value of 1 in my triangle. So I can use Pythagorean theorem to figure out what my adjacent side would be. So I have 1 squared plus this being identified with a squared equals 4 squared, right? 1 squared plus whatever a is squared equals 4 squared. Solving this, so this is 16, this is 1, subtract 1 from 16, you get 15, and then take the square root of that. So then I know that my adjacent side of my triangle must be square root of 15. So sine of t, well, that's just equal to 1 over cosecant, right? So it's 1/4. Cosine is adjacent over hypotenuse, so it's square root 15 over 4. And tangent is equal to opposite over adjacent, so 1 over square root of 15. All right, so number 68, show that tangent of x plus cotangent of x equals secant of x times cosecant of x. Well, tangent of x is equal to sine of x over cosine x. Cotangent of x is equal to cosine of x over sine of x. Secant is equal to 1 over cosine of x. Cosecant is equal to 1 over sine of x, right? So I have here a sine and a cosine and a cosine and a sine, right? Let's get rid of all of these terms in the denominator by multiplying by sine of x times cosine of x on both sides of the equation. When I do that, cosine cancels out with cosine, sine cancels out with sine, and I get 1, right? And then I take cosine cancels in the first term, and I have a sine times a sine, which gives me sine squared. In the second term, the sine cancels with the sine, and so I have cosine of x times cosine of x, giving me cosine of x squared. And this tells me that sine squared of x plus cosine squared of x is equal to 1. And I know that this is a true value. This is a trig identity, right? Furthermore, every step that I did, I can backtrack, right? So I got to this. I could say that I start at this and work my way backwards, right? Until I get to here. So therefore, this directly shows that tangent of x plus cotangent of x has to be equal to secant of x times cosecant of x, because we know that this is true. All right, down here. Let's try to cross multiply. So in number 69, multiply 1 minus cosine of x to this side, and multiply sine of x to the other side. Here we get 1 minus cosine of x times 1 plus cosine of x equal to sine squared of x. Therefore, we get This is difference of perfect squares here, right? So we get 1 minus cosine squared of x equals sine squared of x. And we get to this. Same reasoning as before, right? So we get 1 plus sine squared of x plus cosine of x. Or excuse me, 1 equals this, our trig identity from before. We could work our way backwards and still end up at the identity that we're trying to show. All right. Number 70. We have sine of x times cosine of x tangent of x equals 1 minus cosine squared of x. Same old tune. Tangent of x is the same thing as sine of x over cosine of x, right? So if I replace that, cosine of x cancels on both sides. And I am only left with, on the left-hand side, sine squared of x. And I say that's equal to this, right? But if I add cosine squared of x, I get this identity again. So I can work my way backwards to the identity that I'm trying to show. Therefore, this directly proves it again. I used the same trig identity for all those problems. All right. Number 71. Given that sine of u is 1/4 and cosine of v is 3/4, find negative sine of v minus u. All right, well, we know that sine of v minus u, we'll ignore the negative for right now, from a trig identity. You can find it in your book on that little cheat sheet. Is sine of v cosine u minus cosine v sine u. So that means that we have to find, because we know what sine of u is and we know what cosine of v is, but we don't know what sine of v is or what cosine of u is. We have to find these so that we can use that identity. So what we can do is draw the triangles in a similar way that we did before. One for our u angle and one for our v angle. If sine of u is equal to 1/4, sine is equal to opposite over hypotenuse, our hypotenuse would be 4 and our opposite side would be 1. And this gives us square root 15 as an adjacent side. On the other one, right, we have cosine is equal to adjacent over hypotenuse. In this triangle, we know what the adjacent side is and the hypotenuse is, and we use these to find out what the opposite side is. Then we can use them, these values here, to figure out what sine of v is and what cosine of u is. And that's what I do. Where do I do that? Right? So cosine of u would be equal to square root of 15 over 4. Sine of v would be equal to square root of 7 over 4. And then it's just a matter of taking these 4 values, the 2 that are given and the 2 that we found, and plugging them into the formula. And so I get 105, square root of 105 minus 3 over 16 is equal to sine of v minus u. And just taking the negative of that, we can just switch the 2 signs in the numerator or just write it as negative, right? Gives me this. And that's the final answer. And that's the pre-calc review. So, I hope you did all right. If you didn't get all of them, nice, because some were hard and some were easy. Just keep practicing. Review over these videos, and if you have any questions, bring them up. It's just a matter of practice.